Okay, so I'm going to do a demo on accounts payable. I'm going to focus on invoice processing for a few different reasons. So let me just kind of set it up with a few slides here, particularly just to explain the use case and why it's tended to be a problem before. So invoice processing is something that's typical for nearly every enterprise. It's something that we all can kind of understand as we look at these documents, but it's something that a lot of times is ripe for automation, especially with SPA. So it's high volume. Thousands of these invoices are coming in each day. They tend to be very time sensitive and need to be processed in the same day, and they're often very global. There'll be shared service centers that are processing invoices for a global bank completely. So each of these kind of points to something that you would typically automate with, but the variety of data has limited the effectiveness so far in trying to automate something like this. So the reason is because typically an invoice is easy to understand from a person standpoint. If I ask you to find the invoice number, you'll probably find it very quickly in the upper right-hand corner, and that part's easy, but this is just one document. The larger problem is every document has pretty much its own layout as it's moving together. Now, some vendors are more frequent than others, so you might see the same layout more consistently. However, you can't necessarily predict that up front. So while theoretically you could define all of the rules, typically customers don't, or organizations don't, because there's too many to define and it's too difficult to sustain a high level of quality with all those rules that are there. Vendors get added, vendors change their formats, different shifts in data that just come up as any data set. So to combat this, instead of finding a elegant automation solution in the past, organizations just kind of found a better way to use people. So they added a couple monitors, maybe they made the systems easier to use, but you had people that were opening up the systems, opening up the data, and just keying this in. To manage quality, they'd usually have people set up, and often a maker checker set up, where you have one person creating the record, another person checking what they did. And then, of course, when you have large volumes and you have a manual process, then you have large teams manually processing all of this data. So with WorkFusion SPA, this is the type of process that uses each of the different capabilities of the software because it's able to automate with systems and data. So it's not just about how do I get data, or how do I get data in form one into data in a different system in a form over there. It's about how do you really get access to things like invoices or things like just data that's in documents, and being able to automate from that, not only just what appears in the system directly. So it's beyond the system, beyond just the system connections, it's also doing systems and data. Something like invoice processing, a lot of times the returns are about 50 to 85%, depending on the scope of what needs to be done. I think I actually have a use case here that talks about this. So this is one example that we were working on with a customer where they had a 23-minute invoicing process that was able to be cut down to just 1 minute. This involves connecting with SAP. It wasn't just an internal invoicing system. They actually had SAP that was involved. And here they were looking at the different fields, different values to pull together. Overall, the automation rate was about 92%. There was a little bit of rework that needed to be done, meaning people adjusted some of the data that was found from machine learning. But all said and done, you had about a 58% automation rate across all of the work that was needed to be done. A 58% SDP rate across the documents that were in the scope of this final test. So you can get significant results. So now I want to focus on kind of how you start pulling that all together. So I'll do this slide a little bit later. So let me switch to, I'll just do that this way, sorry. First, kind of thinking through how would you approach this now that you have different capabilities available. So this is where I'm starting to bring together kind of one solution of one process with the different capabilities that are available. So before WorkFusion, you have your manual process, and you can kind of break it down into maybe 4 different steps. You're reading invoices, you're identifying data in the invoices, you're validating the data that was identified, and of course, you're actually entering that data into that system. When you look to pull in automation, you need to apply the right capability for each step in this process to automate it, optimize it end to end. RPA works great for that data entry step. because once you have structured data, you can then easily enter that data into the system. But these invoices probably need OCR to be able to convert images to text, be able to convert PDFs to text, TIFFs to text, whatever, and then using machine learning to cut across the different layouts that are available. It's not template driven, it's focusing on the individual data points, which we'll get deeper into, and then pulling in people where maybe they need to provide that final check. So if you had a maker checker setup, maybe you don't automate the maker or the checker right away. Maybe you automate the maker first and then find ways to optimize the checker in your end-to-end process. So this is kind of one approach of how you start pulling this together. We'll come back to this one for other use cases. But basically being able to pull together OCR, machine learning, people, and RPA within a process. So that is the jumping point to get into the software. So from this, I'll now switch to Control Tower and start showing you in that process. Any questions before I make the switch? Okay. So this is SPA. This is the Control Tower interface of SPA. And this is where developers will go build processes. We'll do that next. Where we're going to focus on this one is if you have a process already implemented, how you can monitor that process within the software. So we're focusing on the production view to start to explain the concepts, and then we'll show how something like this is built. So if I want to kick this off, I have 14 invoices I'm uploading manually here. Obviously, you can schedule this. You can have this look at an FTP directory or a shared drive. You can have this triggered by API. You can connect email up front to be able to ingest this process. So starting with a few documents to begin with, I've used a pre-built process, and now I'm sending data to it. So the first step is OCR. So I click on the design view here again. You'll be able to see that it's starting to make work on it. OCR is now 86% complete. It hasn't started the cognitive yet because it's waiting for data to be sent. But I believe if I click refresh here, it's probably making quick progress, and it's probably now finished OCR, and now it's starting to move these documents into the cognitive step. So I don't want to focus too much on a process diagram. I want to explain kind of what's happening with the data in the background. So I'm actually going to flip to PowerPoint, but more to visualize what's happening here in the background. This slide here explains the data in each of these steps, because again, we're focusing more on data and not just the systems. So we have RPA here at the end, but that only comes in once we have the structured data to work with. So if we start with OCR, this is where we're converting images to text. So we're taking the PDF and converting it to basically an HTML table or an HTML document, where we can now use the digital text to apply other capabilities. First thing we're going to do is try and apply this machine learning model that's been built. When we come back around, I'll show you how this is built. But right now, let's just assume there's a machine learning model that's able to take an invoice like this one and identify specific fields within it. So it's cutting across the different layouts. It's not focused on templates. It's focused on individual data points, and it's able to identify what it can. Now, if it identifies everything and it's able to identify it with enough confidence, then maybe it goes directly into RPA. And maybe it just takes what's generated from machine learning, but maybe then it goes straight into RPA. Or in some cases, it's going to escalate it to a person because maybe it wasn't able to complete the record. In this example, it's looking for 6 fields. And if it doesn't find all 6 fields, then it can route it to a person to be able to work within the process. So this is an example manual task where you have data that has been pre-populated. The fields that it's already been found have been highlighted here. But then you can now have a person go in, review what's already been done, find the field that hasn't been completed, and then finish the record. When it's doing this, this is an extra example of training data that can now make the system stronger. So not only have I resolved this one, but I've also provided more data for the system to learn from to make it better the next time around. It's not focused on this is the specific template that I found and now you have specific rules for this specific template. It's not focused on that. It's focused on trying to understand what are the invoice numbers look like, how do those invoice numbers get formatted, how do they come together, what is the content of an invoice number, as well as what are the context clues that help identify it. What are things like labels and other things that help identify where specific data points come together. Once I've got the data, regardless of whether it was done with machine learning or whether it was done with a pure manual task, now it's ready to be entered into RPA. This is closer to a lot of the videos and integrations you've seen before. It's able to use that user interface, log into the system, and be able to enter the data that was found in the previous steps. This is actually also an example of a high-density bot where you have two bots working on the same machine, and you can see that it's bouncing back and forth between the two different bots, able to work in parallel because it has multiple Windows accounts on the same machine, basically. So this is how the data is moving through. Now, if you're focused on all the screens right now, there's a lot happening in parallel, which is kind of the point here. When you have a high volume process, this is what it's going to be doing with every document that's coming through. The top two steps are actually executed centrally. So OCR and machine learning are kind of happening at the front part of the process. The manual tasks are happening within Workspace. And then you have the RPA interacting with those underlying bots, the VDI or the servers in that final step only. So you're able to work all of this in parallel, maybe optimize those bots because maybe there's other processes that can also use them while it's waiting for the data to be structured. But you're able to do this all within a process and able to bounce back and forth between the different types of automation along with the people that can be part of the process. Any questions here?
Hi, hi Rajiv here. You said that we are working in parallel, but when you go towards the control tower, it shows us the process step by step, right? The first part is the OCR, then obviously the machine learning, and then putting the data in on a maker checker function, right? So I believe if you look at the top left hand side, the OCR is happening. At the right, it is integrating with the UI. So these are not happening in parallel, are they? They are sequential activities, correct?
Well, for an individual document, it's sequential. But while once something's been OCR'd, then it can move on to the next step. It doesn't have to wait for everything to be OCR'd before it moves on to the next step. It can be doing all this in parallel.
So if I have 100 invoices coming in, so it will probably go ahead and OCR all of them first and then move ahead, correct?
It will. If you have 100, it'll probably get 10 or so done before it moves on to the next step. And then you'll have 90 that are in the OCR step and 10 that are in the cognitive automation step. And then it'll keep moving through like that.
So the OCR will happen for the whole volume first, correct?
It will, for each individual document, it will start OCR first, but you don't have to OCR all of the documents to move on to the next step. Once a document is OCR'd, it'll pass that along and it'll continue OCRing the rest of the documents. Typically.
All right. So okay. So if I take an example, if I have two invoices, one will get OCR'd first, then it will move on to the next step, and then this will OCR the second one, right? So it will just keep on happening.
Yes.
Okay.
Yes. So.
Kyle, it's Nathan here again. Oh, sorry, mate. You go ahead.
Let me finish up a point there. Now, if you want to structure it in such a way to be able to only do an entire step first before you move on to that next step, you can do it, but typically we'd have what we call streaming within the software, where once an individual piece is done with a step, then it moves on to the next one. So if you have 30 steps here, you might be doing all 30 steps at the same time. It's just documents are just at different statuses along that journey. So sorry, Nathan, go ahead.
Thanks, mate. So the last time I spoke with Abby, they were sort of touting a lot of this machine learning in recognizing fields as well. So is this the same thing that they would be talking about, or is this like some proprietary, like specifically the machine learning components, right? Is this something that's specific to WorkFusion, or is this still using the built-in Abby capabilities?
So this is using Abby only for converting images to text. It's not using Abby for their invoice capabilities for their different applications they've put on top of it. So Abby recognizes, as all OCR vendors typically recognize, is that converting images to text is not typically everything that needs to be done. Typically you're doing that for a purpose, and that purpose is, in this example, collecting data out of invoices. So I think they have their own invoicing application, and theoretically you could use that. But what we've found is when customers look at both, using the WorkFusion training training WorkFusion to extract their data, they typically get 10 to 20% more automation than they get with just an OCR package on its own.
Yep, perfect. Yeah, these are the questions that are gonna get asked of me. So
Yep.
perfect. Thanks.
Absolutely.
Thanks, mate.
Hey, Kyle. Hi, this is Priyanka from EY. I have a question as well. As a follow-up on this question, the percentage of work flowing from one step to the other, is it dependent on how many bots are available? And how do we specify that? If yes, this.
So it can be. So we'll actually have some new materials that are coming out to get deeper into this. But of these 3 steps I have on the machine on the screen here, the only one that uses those bots, the only one that uses VDIs, is this final one here, where you actually need to enter the data into the system. OCR, machine learning, and even some other rules-based approaches you can do centrally. You can do it with a different approach. So when we get into the installation, we'll talk about how you need to have an OCR server, a machine learning server, and then RPA servers that are separate. The reason for that is the work is done differently than you'd get with typically even other RPA approaches. If you want to OCR something, you're not OCRing from the bots, you're OCRing centrally in the way it's set up here. So the bot is only triggered here at the very, very end in this process. The bot is not triggered for these other 2 steps.
Hey, Kyle, Muni from
Thank you.
Sorry, to add to the question Priyanka raised, right? In what scenario you can call this as a different process unit? I'm going back to your reference of process unit, right? So I assume all the 3 steps will fall into the single process unit because it belongs to one location or region, right? But let's say if these invoices are split across multiple regions or like multiple locations, is that when you call it as a different process unit, wherein the exceptions are going and sitting in their workspace? Help me relate to this, right?
Sure. It's a simple way to talk through. So this is one business process. This is implemented as one business process. If I go to the business processes screen here, I can see all of the business processes that I have in this instance. So in this particular example, we have 8 processes, and each one is its own setup. Now you can see that I have a couple different invoice processing English ones. So in this scenario, there's actually a couple here that are used for training and actually for development purposes. So these likely wouldn't be counted if we were to do an audit. These would just be part of the ones that were used maybe in a development environment, which is kind of what happened here, versus what would be being done in production. So more likely what would be counted is this invoice processing one here, the invoice processing one that's Spanish, it's configured as a different process, and then you have invoice creation and then 3 payments processes. So if I was to audit and say how many process units are in this particular instance of the software, it would be 1, 2, 3, 4, 5, and 6. So it'd be the 3 invoice ones and the 3 payment ones.
Got it. Thank you. I think I have a better understanding now.
Sure.
Kyle, hi. Sanyog this side. I have a small question, actually 2 of them. The first one is, in the demonstration that you showed us that the OCR kicks in, then there are 2 variations, either a human agent does some part of the work, or you have the ML pushing through it, right? Now the first part of the question is, what number of documents will you require for the ML to eventually learn through the various types of formats that it is going to process? That's one. The part 2 to the same piece is, what is the what is your view in terms of the attended automation that you're calling out on the human agent doing this activity for putting the information there? And finally, the third piece is on the process unit side. How does that come into the picture during all of this working mechanism as such?
I'll answer the first 2, and then I'll need to get more information on the third one. But let me cover the first 2 to start. So, how many documents does it take? We have a couple slides on this, but just to give you a sneak peek, something like invoices. Typically, those POCs are built with around 500, 800, sometimes 1,000 invoices to be able to build that initial model. We can walk through a few phases, but typically you kind of break that up into at least 2 different steps. So maybe you train it with 300 or 400 documents, and then you train it again with the remaining 400 to show some level of value there. We can talk through that if we need to, but something like information extraction, like invoices, usually it's a few hundred. 500 to 800 is a good range to kind of think through. Your second question on the attended side, when we're doing SPA, we're not focused so much on attended automation. Now, there are ways to have end users trigger automation, but the RPA itself doesn't happen on individual users' desktops. The RPA that we were showing, that all would happen in an unattended manner on RPA VDIs or servers elsewhere. So when we're engaging users, we're doing it through the Workspace platform, but there we have a specific manual task for them to perform. And then once they submit or complete that task, then it would move on to continue the RPA or continue some other piece of automation. Does that answer your second question?
So essentially, sorry, yeah, I'm on just on the second question itself. Basically, what you're saying is that ideally we would want to keep it, unattended, because it will lead us through for a let's say a higher straight through processing, automation. Right. But at times when you will require some judgmental elements to kick in, does WorkFusion have the capability of passing on the controls to let's say an agent at that point in time and then picking it up again, because you have the workflow engine as well, so you can keep a tab on what the agent or how much time the agent is going to take on his or her part?
Yeah, so there's a couple ways to do it. So the typical way that it's done is when you're using RPA, you do what you can do, and then you pull the data once it stops. So basically, once you know that you need some expert judgment, then you pull the data from that state, whether it's collecting all the data from that underlying application, or even in some cases just taking a screenshot, and then you'd free up the VDI. So that means it can the RPA can then go do other things while this data is sent to a person in Workspace to be able to complete the action that they need to do. And then once they've completed that, then it has enough data and knows the steps to be able to go finish that job. Now that's if you want to free up that VDI. In other cases, maybe you don't want to do that. Maybe you want to hold that VDI hostage until someone completes the task. In that case, then you can do a similar thing. It just, instead of freeing up the VDI, it just stays where it is. Someone then has to complete the task, and then they can send that data and then complete that particular function, because it's just pausing there while it's being completed.
Got it. Thanks. I think we can move on to the third piece, please. Yeah.
Well, can you clarify that question?
Yeah, just trying to understand. So, when we started off the session itself, you said typically, automation providers look at number of bots, whereas WorkFusion looks at it from a process unit perspective. And I think Rajiv was trying to understand how do you differentiate, this when you talk about different geographies kicking in, different number of processes kicking in. So from that perspective, if this, in this accounts processing process that we're talking about is for multiple geographies, has some variations built into it, are you telling us that, we'll need at least one per each geography, because there are going to be some variations in each one of them?
So it's going to be a little subjective. So I can't give you a full concrete answer. So the reason why is, for this example, just from the demo environment perspective, we took invoice processing English and separated it from invoice processing Spanish. So we had 2 different processes to facilitate that. Part of that reason is because the OCR engine, the way we've set this one up is this step is for English and the other one is for Spanish. But there are ways to merge this together when you're doing implementation. The OCR engine itself, I think, can be set up to do both English and Spanish at the same time, so it can be able to work with both languages, as well as the data that you need to extract. If you identify one's English and one's Spanish, then maybe instead of having one model here, you have an English model and you have a Spanish model. In that situation, you might want to have them as separate processes, because you're using different OCR, different machine learning, different fields, maybe different validations to pull it together. But in other cases, maybe it's the same. maybe the invoice data that you need for English invoices is the same as Spanish invoices, and the people that do the processing, they're bilingual anyway, and they can work with both languages, and there's a lot of cognates, so maybe it doesn't really matter. So then maybe you implement it as one process. It really depends on the data and depends on what makes the most sense from a configuration perspective, as well as a monitoring perspective. Because in some cases, even if technically each step is actually the same, different teams might want to monitor and keep their data separate from the other team, just because the process is similar, but the organizational construct around that process is actually different. So there might be reasons to do that as well, that are less to do with the software and more just to deal with how the enterprise is thinking through it already. So it's not one hard answer. We're giving you the freedom to be able to pick the right setup and be able to focus more on what work needs to be done, how can you make that optimized, and how can you make sure that the business is getting value, regardless as to whether that's 2 processes or 20, regardless of whether that's 2 bots or 200.
Got it. No, Kyle, this is really helpful. Thank you so much.
Excellent.
Hi, Kyle. This is Radhika. Just a question on how easy or difficult is it to build or change these processes at any point of time?
Yeah.
The steps and so on.
Let me finish this one up, and then I'll get into the building side of things. So it's a good question. So it's good reason to get back to the clicking through some stuff here. So as I've set this up in the process here, let me click into, let me just show you a little bit more of what's happened. So as I click into this, I can see that within my cognitive bot, I have a handful of boxes here. There's really 2 that are doing the majority or going to get majority of the focus. One is this step here where it's actually applying the machine learning model. And then the other one is this step here where it's actually starting to send work to people. So in this example, you can kind of talk through what's happening with everything that's moving through. So when you do machine learning, it's trying to identify the specific fields. In this case, there were 6 fields that it needed to identify. For those 14 documents, you can see 14 out of 14, it tried to identify each of those 6 fields. When it identifies it, it also understands the confidence that it has in each field. So this is where machine learning starts becoming less rules-driven and starts getting more probabilistic in its nature. It has a little bit of certainty that's built in, and we'll kind of talk through different pieces there. But essentially, it's trying to understand not only what data did it find, but how confident was it that it found it? Basically, how similar is it to other data that it's seen before? So when it moves through, you can then have high confident data get automated, and they would move through these next steps in the process. And then you can have or you can have other situations where maybe it found some of the fields, and other cases where it didn't find any. Your most common state is actually probably going to be this partial automation situation, especially as you try and find more and more data. So while everyone wants to get to STP and find all of the fields, that's great, and you'll get there as you get more data and as you are able to optimize your models. But in a lot of cases, you're going to have situations like each of these where it didn't find all 6. It actually found some of the 6, and it can pre-populate the values. It just can't solve everything. And I'll walk through that a little bit more. And then for the final path here, there might be situations where it didn't find anything, meaning an invoice came through or a document came through and it didn't find any of the 6 fields. Could be because it was a very poor quality scan. Could be because it's not even an invoice. So situations where it just didn't know what to do at all and it's passed to a person. Regardless as to whether it found some of the data or none of the data, it uses the same task to facilitate this work. These rounded corner tasks in the white color here, these are what are sent to people through our workspace capability to then come in and assist the automation. So I'm going to jump to workspace, but just to kind of close this one up here. If I close this box, regardless as to whether it was done with RPA, or sorry, with people and machines, or just machines, it then moves on to the next step to enter the data in RPA. This whole cognitive bot here, this green box, is all designed just to structure that unstructured data so that you can then use it for next steps downstream.
Hi, this is Rajiv. Before we go on to the next box, if you can please expand this box again of the cognitive automation. I just wanted to understand first, when you define that confidence, it is both of completeness and accuracy, correct? whether I get the 6 fields or not, or whether I get them accurately or not. Both of them, right?
Typically when it's automating, we'll touch on this a little bit more when we build it, but you have the trade-off between automation level and accuracy level. Let's kind of park your question for now, because I'll touch on it a little bit more when I have the screens later. It's a good question. Let's just come back to it a little bit later.
Sure, no problems.
Well, let me show the workspace here just so you can see a little bit more of what's happening with those tasks. So if I jump into the software here, this is workspace. This is where you can facilitate tasks. So what I'll do, if I hit accept, it's probably going to log me out anyway. Okay, so Control Tower is for developers to be able to build, for operations people to go monitor processes. Workspace is for SMEs to come in and actually work within the process. So this is how you're facilitating work to people that typically have been doing the work already. They're just doing it maybe in a slightly different environment, and maybe in more of an optimized way. So when I log in, I can go find tasks that are available to work on. I can click on, in this case, they're all invoice tasks, and I can go find some fields to look at. I click on this view button and it gives me a preview. I click on accept and it's going to assign this record out to me. So I hit accept, and now it's saying I own this particular document to work on. No one else is able to touch it. It's actually counting down how much time I'm spending on it, and I have all the work I need, or all the information I need to complete this task. I have access to the original PDF, so I can go find that source file here if I need to and do a final review. But because it's gone through the machine learning, because it's tried to find what it could, it's got because it went through OCR to convert it, and it went through machine learning to find some fields, I now have a text version up top, and I have the data that it found identified within the document here. So as a quick review of this, I can see I need to find 6 fields. One is the invoice number, which I can actually easily see that it got this one wrong. So I can fix that very, very quickly. I just highlight, I just delete one, I highlight, and I now select the value. So here, this is an example of where the machine found something and it was pretty confident in it. But now I'm providing an example of where it needs to adjust its understanding because I actually corrected the value that it found. So there are some of these rework situations that can come up. But things like the date it found correctly, the supplier address it found correctly, it didn't find the supplier name. It didn't find the supplier name with enough confidence to show it here. Maybe it found something, but it just wasn't really sure what it found, so it didn't show that it found anything. And here I'm just going to provide that value. And then in this case, there's no bank account number. If I scroll down, like there's nothing there to select, so I just leave that one blank. So in that situation, it's another situation where it knows that a bank account doesn't occur in the document. There was nothing to find. So by identifying each of these fields, this is a key part of the machine learning setup, and this is how you differentiate between a templated approach. What I have not done is I have not identified, go to this document based on this setup, go to the invoice number, find a colon, find a white space, and then grab the characters that occur afterwards. It's not defining these regular expressions, as you might call them, or some other kind of rules-based setup to go find the data. What it's trying to do is identify, this is an example of an invoice number. This is, in that example of the invoice number, it's 7 digits in this case. And if I look across the entire training set of 500, 800 invoices, they're all going to have some consistency of what invoice numbers look like. And there's going to be some underlying patterns of how you would identify where it occurs in the document. There's this label in front is the easy one, but then there's also other things to understand, like it typically comes near a date that gets identified. It's usually above the document, above the supplier and bill information. So it's trying to understand all of these underlying patterns for each data point. Effectively, it becomes a model for each data point in the process, or in the document. It's not just template, find rules, it's identify for each field, how do you identify that field amongst all of the data that it's situated inside?
Kyle, Ganga here from Capgemini. Yeah, my question is, you said, the bot did skip the name of the company. So the next time, will the machine learn, when this kind of template comes in again, so it will pick this name, or again it will skip?
It depends on the underlying confidence level of what happened there. So if it was just below the threshold, then maybe this is the example that it needed to go above that threshold, and then it can automate it the next time around. Or maybe it's not even this particular company that comes through that is that differentiator. Maybe the next document that someone reviews also missed the supplier name, and by adding that other supplier name, that's going to be enough to make it do better the next time. Or maybe this is just an example that it's really tough to understand, and it might take a few examples for it to really understand supplier names in this arrangement of the data. It's not template driven. It's understanding the individual data points. So it will depend on the data set, but you're planning on multiple, you're planning on the combination of powers of getting lots of variety of the data coming through. So ideally what you have is when new vendors get added or when an existing vendor changes their layout, your automation rate is not affected because it's able to understand invoices with enough detail or whatever your data set is with enough detail where even that new example that gets added is not different enough from stuff in the past. It's not a hard set of rules, but the data is similar enough in its content and its context that it's able to automate that data as well.
Hey, Kyle, this is Swapnil here. Given that confidence levels are involved, what happens if there is a false positive? How does the system come to know?
Yeah, so that's a piece to be able to handle a few different ways. So one is you can add validation rules and other pieces in to your data set to be able to automate with that as well. So you can do things like compare formats of the data. So for example, the invoice date here, it's actually a date field. You can see that the value here is not the same as how it gets extracted. So there's a conversion that happens here. So that's kind of a simple one, but it can be more complex where the values have to map to a specific master data list, something like that. Another one can be how you use data across the overall process to be able to compare that it's coming through cleanly. So in some cases like account opening, a lot of times you'll get documentation about a person. You might get their passport or their driver's license, but you also had the form they filled out that had the data in it anyway. So the job there is to take a structured data set, the form they completed, and compare it with an unstructured or not really templatable setup with maybe their passport and a driver's license, depending on your country. So there you have a data that you're expecting, and you have the data that you're trying to compare it against. So there you can do a comparison to make sure that those things match up. And if they disagree, then you have some reconciliation activity built in to be able to compare it. Another one could be maybe you have fields within the process where you're comparing across that as well. So in trade finance, I'll get into that later, you might find the invoice amount in one part of the process, and you might find that same value in a different part of the process and compare those and make sure that they match up. And if there's any issues, also have people review. The third piece of that is then also how you can use people correctly within your process. So if you remember when I first set up this particular process, I said there was 4 steps involved. There was 2 people usually involved. There was a maker and a checker. So this process is actually designed to show a maker and a checker, but the maker is completely with automation here with this machine learning setup, and the checker is completely with this, this manual task here. So you can set it up where everything goes to a person to review, but so you're not going to get STP in that example. You're always going to be sending it to people, but instead of sending it to 2 people every time, you're now only sending it to 1. So you've got significant automation powers built in, significant savings, even though you're still having a slightly manual-driven part of the process. And that's where I mentioned the expert part of the workflow setup, where you have people that are strategically placed in your process to make sure you're getting the quality that you need.
Got it, Kyle. Thanks.
Mm-hmm.
Kyle Mooney here. Go ahead.
Thanks, mate. So Kyle, you mentioned obviously the more invoices or documents that we scan, the more likely it's going to be that it picks up that correct invoice number. Okay, so I think we understand that. This being a software as a service, do you sort of collate data from all the users across all your different customers to improve that, or is this something is it just your own data set that it does this, or you know, is there any kind of that social mixing type activity going on?
So it's a good question. So because it's pieces I haven't brought up yet, and good time to bring them up. So when you are training a machine learning model, a machine learning model is basically the combination of algorithms and then tied with data to create a predictive model. So that data is part of the model. So that data is used to train and build and be able to understand the underlying patterns. Now, if you then have a model for a customer, technically you can't use that model for a different customer because not only would they maybe have slightly different data needs, but also that model includes the other customer's data. So you're typically not using data from one customer to another because the model maybe isn't exactly what they need, as well as you can't be sharing customer data across them. Now, there's a few exceptions to that. Well, actually, one other piece before I get into the exceptions. So the piece of that is also that you're doing machine learning typically on the customers on their premise behind their firewall. So you're doing machine learning inside the organization. You're not doing machine learning in the cloud. So while the subscription of our software is kind of designed as a software as a service, it's software as a service in the sense that people are paying an annual subscription. It's not software as a service that people are always doing a cloud deployment. In most of our customers at this point, and almost all of our banking and insurance customers, they have an installed on-premise version of the software, and there's no communication to the outside world. So you're able to build that machine learning model on regular hardware, no GPUs, and you're also able to do that within their premises for their data, for their setup. So in that situation, the data is deep into the organization, and you can't get it out anyway to share it with a different customer. But
okay, great.
Sorry, long answer here, but it's a good topic. There is the ability to do some other things with it. So actually, this process that I'm showing you here, this is an example of where we did take data from multiple customers and combine it into a model. So this is a cloud version of a invoicing setup for these 6 fields. It's actually called Invoice Bot, and some of you might have access to it. There'll be more instructions coming out later where you can demo from it. But this is an example where you can take data, feed it through, and get some data coming out of it that's trained on multiple customers' data. But it's not for production purposes. So because there's not that separation between the model and the other customers, this is just a demo environment. It's not something that can be used for production. Because if you try to install it behind someone's firewall, you're now taking data from multiple customers and giving it to another customer. But this does give you the ability to have that kind of cross-trained model across customers to have a superset. And then the other piece of that is some of our partners are also creating smart apps or creating more of a service from a data perspective to be able to take those underlying data sets and apply them to multiple of their customers, kind of more from a BPO standpoint.
Thanks, mate.
Yep. Sorry, it's a long answer, but it was a question I like. So.
Kyle, the kind of requirements that we're getting from our clients, right? Mm-hmm. When you're having an operating model with the cognitive implementation or AI implementation, when the process is in production, you always get the new invoices, new type of data fields, and then there's always a training that is, retrain the models or rebuild the models. So how does the whole thing works? I'm not sure if you're covering this in the subsequent slides, but my question is largely on training the new data sets, right, or training the new items, mm-hmm. new type of formats, and so on and so forth. So where does that fit in the WorkFusion SPA tool that you're showcasing now?
Yeah. So let me switch to the other demo, kind of how you build this, and we'll try and touch to some of that. There were some other questions before. Let's switch to that, and then we can try and address some of it here as well. And obviously, sure. Keep asking questions. The engagement's excellent, so thank you for these. So let me switch to building this process. So to build it, actually, I'm going to start with the RPA step. So I'm going to start at the end. So there is now, and then there will be even easier in the next few months, 3 ways to build this. So you can build with the image recorder, and you can see that with RPA Express. In some cases, it's useful for other situations as well. But you have the image recorder that you can use to build. You have the object recorder setup, or the object-based setup you can do. Right now, it's a little bit more developer-heavy, but there'll be an object recorder setup as well. And then the third one is to be able to do it with code, being able to just script or actually code each of the steps there. So I'm going to start with the coding environment one, just because that's the one I have ready to show you. So I'm jumping in here. This is the coding environment of what it looks like, and this is the code for that step in the process. So a lot of people, a lot of the RPA developers in here that would have done some of the setup, they might have written a step like this, and they've been able to do the real robustness and the tightness you need to do with the code to be able to do the setup completely. If you are doing it with the recorders, kind of same general setup, you have your artifact of the steps pulled within the environment here. Once you've done your setup from an RPA perspective, I'm not going deep into it here because I'm trying to leave that for the developer courses. But once you have your setup and you want to publish it now, I can publish my bot task to a new business process. So it's going to take the code I had there, and it's going to find my environment. Here it's linked to this particular instance of WorkFusion or of SPA, and I'm going to give it a title, Invoice Processing. And it's already been connected. It has the different setup there, and I can now publish it to that particular instance of the software. So this is going to open up Chrome. Hopefully I'm still logged in, and then it's going to create the new process to build from. So I've built it in one of the environments. In that case, it was the coding environment, and now it's exported it up here into a new process for me. So now the other 2 steps we had was we had OCR, and then we had our cognitive bot in the middle. Well, I don't have a model right away to use, just pull the cognitive bot in, so we need to build and start collecting the training data to kind of show you how the machine learning is being done. So to do that, I need to move my RPA step here to the end. And this is the kind of edit mode. That question had come up. So I had shown you the processing mode, the view mode before, and now I'm showing you the edit mode behind this as well. So now I want to take my OCR, and since it's a kind of generic component here that is kind of literally just converting images to text, it's actually applicable across many processes that need to do it. And it's not focused on individual use cases. It's just a component in the middle here that's converting images to text. So I can just add that in, align it correctly, add that in, and now I have 2 of my steps already designed. And then the third piece is I need to get that machine learning model built in, and the core of that is the manual task. So when we get into the solutioning side a little bit later today, I'll emphasize the need to understand the data, and the need to understand the data is important because underlying the machine learning is typically a manual task that's able to get the data and understand the data of how this comes together. So this is an example of that manual task. Here I can drag it in and I can start from scratch if I want to, or I also have the ability to work with templates. So I've connected the process end to end. I can dig into this task and define it. In this case, I actually have a template that I use that's been set up to be able to work with this. It's an information extraction step. I have an identify invoice data step that's able to kind of get me up to speed quickly here. So I click this one. It's going to have everything pre-populated for me, but you can see where I could make adjustments. So I've got the title. I can maybe adjust this to what I want to do, and then adjust it for purposes here. I have the 6 fields that have been predefined, but I could go in and I could define another field if I wanted to as well. I could add another field to do the setup. So the other piece here is we need to make sure that this manual task is set up so that the machine learning can trigger in the background. So what you want it to be doing is, as you're collecting data, as you're collecting the initial 100 fields or whatever, you're collecting that data in a certain spot, and it's able to build the machine learning off of that. So I mentioned before we're automating systems and data. Well, the data is all captured within the software itself. So each step along the way, all of that data is being captured, and in some cases you can store it in a special area to learn from. So we have what's called data stores, and a specific type of data stores are automation training sets. So I go into the automation training sets here, and I can see across my environment, what are the different data sets that I need access to. I can see that there's some stuff about Swift messages that have data here. I can see that there's invoice data that's being collected for this as well. So what you're doing is you're building up these training sets with your data that's basically been tagged, and you're able to learn from this and relearn from this over time. So I need to identify for this manual task where I want to point the data to. So I go in the task properties, I go into advanced options, and then I click to this automation tab. And here is where I've identified what the machine learning model is I want to do. In this case, there's this specific one for invoices, but it could be more generically information extraction and classification. And then I have my training set that I can define here as well. So this is where I can link it to an existing data store, or I can create a new one for it to capture the data. But the key point here is you have a manual task. In that manual task, you want the machine learning to understand how it's able to take the inputs and convert them to outputs. So I do that by saying I have a task. I need to identify kind of what type of machine learning model I want it to be. I'll show a little bit more reasons for that later. And then I want to point that data to a specific spot, so it's all collecting it all together. Once I have that, now I have a task that's able to collect the data and then automatically trigger the machine learning to take over the process. So I click apply, I click save, and then I can execute my process and start collecting the data. So in order to run this, just to kind of finish the demo up here for this piece, I click add, I find my invoices. In this case, I have them manually, but again, you could set this up with more RPA or APIs or whatever you want. I find those invoices that I want to upload, and I upload the same 14 invoices I had before. So now when I run this, it's going to always do the OCR, but instead of doing machine learning that I had shown in that video, now it's going to just go directly to the manual tasks. And when it goes directly to the manual tasks, it's not going to be pre-populated because it hasn't been trained yet. It can't do that pre-population. But what it can do is collect the data to then build that machine learning model over time. Everyone with me so far?
Yeah, and Rajiv here, can we pause? So in a company we'll have loads of invoices already stored somewhere, right?
Mm-hmm.
Can we feed that into this machine learning model before even going ahead with anything like automation?
So you can use historic data to assist with this. And there's two types of machine learning that we'll focus on primarily. There's information extraction, like we're seeing here, and then there's classification, which I'll talk on a little bit later. Information extraction, like invoices, is useful, but the data that it needs isn't just the invoice and then the data you got from the output. It actually needs the in-between. It needs to know where those values were found within the document itself, which means if you just have a PDF and you just have the table with the data that came out of it that someone keyed in, that is not useful as is to be able to train the machine. However, with a little bit of extra scripting, you can convert those documents with OCR into text, and you can take those fields that were found, and you can try to auto map them in the background, and then you can auto tag your documents to be able to use them. Now, in some situations, the values in the values that you need might not be unique, so you might need to adjust those values a little bit to make sure you're finding the right ones. And in some cases, the data does kind of merge and evolve over time. So if you focus too much on the historic data and not enough on the recent and the current data, you might not have as good of results right out of the gate, but you at least could have a starting point to expedite that a little bit. So yes, you can use historic data.
Okay, thank you. And we're going to talk about that confidence level as well, right?
Yes, so that's the next step. Yep. So at this point, when I'm collecting these manual tasks, when they get generated, I don't know if I have one in this instance here, but when I do these manual tasks, I'll just do it here. When the task is being created, and I have my task here, this is the right one. So when this task is set up, you can see that I'm not collecting any of the specific data fields, or I don't have anything here. I need to do all of the work myself because the model hasn't been created. But when I'm doing this is collecting those examples that it's starting to learn from. So people are working here in Workspace, they're collecting those examples. That data is being stored within Control Tower to be able to learn from. And then the machine learning is actually experimenting in the background to be able to learn from it. So what is that doing? Let me jump back to the software here. So if I go to the business processes screen where I was talking about specific the different, we could see the different process units. So you can see there's additional process units, but one of them here has this automation available tag in it. So what that means is this particular invoice processing has more automation that could be available to be able to apply to the process. So I can click into this one here, and I can see basically what's the trade-off I have between automation and accuracy for this particular task at this moment in time. So let this load here. You can see here that we have accuracy at the bottom, and then we have automation rate on the left-hand side. And these are trade-offs. The more accuracy that you want, the less automation you're probably going to get. Right now, this is kind of a little bit of a mountain, and that mountain's going to continue to grow. Initially, when this data set was created, it probably would have been in the lower right-hand corner here, and now it's being scaled up to do more and more of the work. The key line that summarizes this is it says the cognitive bot replaces 35% of the manual tasks with an accuracy level of 98.5% or above. So that's kind of the default setting. And I'd be able to apply this, and it's saying basically if you fed it 100 invoices, it would be able to take 65 of them and pass them aside and say, people need to do these, I don't know what to do. But for the 35 where it is able to apply automation, the data that's coming through is going to be 98.5% accurate. Now, maybe that's good, or maybe you want to get more automation. Maybe you want to say, actually, I know my average person in this case is only 90% accurate, so I want to still get higher data, so maybe I cut this down to 95%. And when I change that, I now get a little bit more automation. I now get 48% automation, up from the 35 I had before. So now about half the data is getting automated, whereas before it was only a third. The data that's coming through in this case isn't quite as clean. There's going to be more errors that are involved, but maybe this is where I have that extra checker that's involved in the process, and they're going to take that 95% data from the model and then make my process 100% accurate or 99% accurate, what have you.
Yeah, I mean, I understand the trade-off, but I'm not sure how it will work when we are trying to, pitch it to the customer or the client, because they will probably say that we want high accuracy and high automation percentage as well, right? So, yeah, I was just thinking about it, what to say to the customer, because they will not compromise on accuracy for automation percentage, right?
That's where you really have to work with them and make sure they understand what they're applying the automation to. Because about every customer is going to say, we have 100% accuracy to accurate data. And every customer that says that is lying, because no one has 100% accurate data. There's some level of error embedded within there, whether they know which ones are wrong or which ones aren't. So 100% accuracy is infinitely expensive, but some level below that, you can find ways to work through it. The average person doing manual work across any use case I've come across, the average person is only about 90 to 95% accurate, which means they've come up with other ways to be able to go from the average person being 90% accurate to get to the 100% accuracy that they claim. And the way they do that often is with a maker-checker process, or I've seen within even the payments world, maybe it's 3 or 4 steps, 4 sets of eyes that are looking the data that's moving through. So when you're looking to automate, my recommendation would be don't look to automate the entire thing, meaning you're not pulling the entire automation in, or the entire manual process into automation. You're strategically including people to be able to make sure you're getting the quality that you need. And you want to do it that way, especially when you get into compliance situations, because you want the person to be involved to be able to just confirm that there's people, that the data came through cleanly.
Yeah, I mean, that's the challenge with accounts payable specifically, or using OCR, right? You still need people to eyeball the data, and that takes away the productivity, right? So, yeah, obviously there has to be a mix of cognitive so that we can ensure that it's accurate as well, or probably can be automated.
That's why we're not saying, when I pulled the first slide up and I said with accounts payable, you're usually getting 50 to 85% accuracy or automation. You're reducing the work by 50 to 85%. I didn't say 100% on purpose. People are still going to play a role within automation. Even if you do RPA, there's a lot of exceptions with that as well. So you're not expecting people to be fully removed in the process, but you're definitely finding ways to make them more efficient. And the efficiency should be the focus rather than what's the highest level of automation rate that you can achieve.
Correct. Gotcha. Thank you.
Okay. So just to kind of finish the demo piece of this up here, when I hit the apply recommendation button, if I'm happy with that 95% as an input level, that's now going to take my business process that before had that manual step within it. It's now going to convert that to the cognitive bot that you see here. So now I've added machine learning, and now when I feed it new data, it's going to route or trying to identify the fields that it can, assess its confidence level in those, and route it accordingly, whether it's to people or even straight through within the process. Now, a final piece I kind of skipped over before is this auto QC part of the process. So if something gets automated, I have this statistical quality control here, this QC step. Even data that gets automated, you still might want to monitor and make sure that that's coming through cleanly as well. So even if you're getting STP, you still might want to sample some of those that are getting automated, because you still might want to monitor what's moving through. And that's an optional step, but typically customers are doing that because they still want to ensure, even though that they're automated, that the automation is coming through cleanly. And just have an easy way to do that, which actually is using that same manual task we had before, just putting it in a different spot where it's checking the automation as opposed to assisting the automation. So that's kind of an extra piece of it there, but I wanted to kind of introduce that concept. So that's two demos that I showed you. One is to show you how this executes in production, basically how you can see how the machine learning is able to identify some of the data, use people to help finish it, and then use RPA where RPA makes sense, OCR where OCR makes sense in an end-to-end process. And then I did the build demo here where you can see that the manual task is the core of the machine learning part. You can automate around it using RPA, using OCR, using other technologies. You have that manual task that can collect the data that it needs to be able to convert that into machine learning afterwards. So hopefully that gives you kind of the two different sides to it, how you build it and what you need to look at when you're building it, and also how it's executed and how it comes through, how data is fed through, and how it moves through each of those steps.
Kyle, I've seen in the course structure, right, the Java 70% and Java 50% capabilities and all that. Where is Java fitting in and all to it? Where is that scripting or actual coding coming in? Is it like the building the ML model, or the RPA portion is where you use the JavaScript?
It's both, actually, to some degree. So you definitely use a Java-oriented view for the RPA side. So technically, you're using some scripting or coding, depending on how deep you want to go into the Java side of things for setting up RPA. But then you also have, within the machine learning side, there's the machine learning engineer training that's focused on making models better. So the machine learning engineer is being able to take kind of what was started with the demo that I had. I mean, it's a demo, so as you go through more complex situations, you might need to do more work with it. But having that deeper Java experience is able to go deeper into the machine learning. So we're releasing a SDK to simplify some of that as well, but that does still require a deeper level of Java understanding to get into the machine learning aspects there. Doesn't require a data scientist, but does allow you to do a lot of work from a machine learning perspective, even with more just a typical engineer background.
Got it, Kyle. It's more Angular JavaScript, is it, rather than actual JavaScript, if I understand correctly, because that's what the underlying language these days being used for the ML models.
It's Java more so than JavaScript, but
I believe it is Groovy, I guess. So we saw a piece of code which is Groovy, I believe.
Yeah, so there's a couple pieces kind of rolled in together there as well. So underlying the RPA, we do have a Groovy shell wrapped around it. And this is where it gets a little more complicated, and I don't have a clear path on how to explain it. But you do have different aspects of Java within these. I'd say to refer to some of the documentation on knowledge base as well as within the course descriptions as far as what specific languages are used and how they're pulled together. The stronger the Java developer you are, the quicker you're going to pick up each of these different aspects. But there are ways to even have a lighter Java understanding to be able to still work with these tools, and with the business user stuff, being able to not even code at all and be able to do some of the RPA.
Thank you.
Mm-hmm.
Thank you.
Okay, so let me talk through a couple pieces here, a couple explainers to kind of help with the topics we talked about. So again, machine learning is about programming by giving examples. The more data you feed it, the more it has to understand, the more it's able to kind of create decision trees in the background, even though decision trees are more the easy way to understand it. From a person perspective, you get into real machine learning, you're going to get into more complex like hyperplanes and that sort of thing. But basically you have the way that it's able to weight and look across the different patterns and features that it's able to identify in the data to be able to apply that to processes. Typically, when you're applying machine learning within a process, if you think it's easier to think of it more of specific tasks that you want the machine learning to do. These are 5 very common tasks you come across within the machine learning world. The 2 on the left are the ones that are most common within the intelligent automation world. And we'll go deeper into this in the solution citing in the next module. So you have data extraction, which is focused on what we were showing there, getting data out of invoices. And then you have data matching where data extraction is not just invoices. I'll emphasize that a little bit more. It's not just invoices, but the example we had shown was invoices. You're basically getting data out of documents, doing it from a machine learning approach. Matching or classification is a different approach where you're not getting data out of it, but you're trying to convert it into other data points. You can see that there's different algorithms that are available. When you're doing data extraction, you're doing a different set of algorithms than the others. So a key aspect I didn't focus on yet is when you're doing machine learning within WorkFusion, even though you're using regular hardware, you're still able to experiment with lots of different models in what's called process auto ML, automatic machine learning within the process. That process auto ML is going to experiment with different algorithms in the background, the different data extraction algorithms or the different matching algorithms, and be able to understand which ones are working for the data set today. And then as it's moving through and getting more data, which ones maybe that it evolves to. So the question came up before of how many examples does it take? Typically for data extraction, it's only 500 examples. And from those 500 examples, maybe it's one of the algorithm works well with low data, maybe another algorithm works well for larger data sets. But the data is going to continue to train and get better over time. You also have different types of data that you need for matching to be able to pull this off. It's not just different algorithms, but it's different data and different amounts of data. Here you need more of 1,000 examples to work off of to be able to build this rather than 500. And it's 1,000 of each type because it's trying to distinguish between different buckets of data. I have a slide that talks about that a little bit cleaner. But in either case, we're talking about hundreds and thousands. We're not talking about hundreds of thousands, which is a lot of times what you get when you go to deep learning and some of the more cutting edge technologies, which are great and are things that we're incorporating as well. But a lot of times it's so much data and takes you so long to build them that you don't get any value out of it, or at least the value is a long time from then. especially in cases where you have lower volume or just need to get access to it now. These types of approaches allow you to get good enough automation and apply that into your process to start achieving value today, not in the future. So keep these data extraction and matching, keep that mindset there a little bit. We'll revisit that a little bit more in the solutioning, but we'll keep going through this as we go through the solutioning side of things. We'll keep re-emphasizing that just to kind of drive it home, but kind of introducing them here. Another way to think about this is how the data is moving through. So actually, I skipped over this before. So in the middle, we have what we had been calling our virtual data scientists. We're actually going to rebrand this the process AutoML that I was talking about. So within the demo, what I basically talked through was you have data that was arriving. People were working with the data, and they've completed it as part of the process. But that data has also been packaged up and sent to the machine learning capability to now experiment with those models. You have those different experiments running in the background. It's trying different algorithms and trying to reproduce the data that it's found. And at some point, then it's able to identify what's the best algorithm that's available. Once you have an algorithm, that's where that flag comes up that says automation available. You can assign your trade-offs, and you can now package your automation and operationalize your machine learning into your automated process. People are there, of course, to monitor the quality and assist in low confidence situations. But you have the ability to build, deploy, and monitor that automation all within one key aspect, one capability of the software. So somewhat repetitive, but it's a good explainer to kind of walk through those steps and how they come together. Then a final piece. Let me jump ahead here. I focused a lot on machine learning, but also keep in mind, we also have a unique approach to RPA, of how RPA is coming together. Machine learning is the new concept. Everyone likes to talk about that, but we also have a better way to do RPA because you can be more efficient with the bots that you have. We mentioned that you had the centralized processing for things like OCR and machine learning. Because you're doing a lot of that centrally, you're not doing it with the bots, so you can use the bots what they do best, which is interacting with the user interfaces. So when in the process, it knows it needs to get access to an app, it knows which bots have access to that app, it can acquire a VDI, it can send the instructions to the VDI and complete that particular task, but then it can free up, well, if there's exceptions, it can pass it to people. But then once it's completed, it says that it's done, and it can free up that VDI for other processes to come in together. So you're able to really optimize your bots because you're able to focus the bots on the UI work and not focus the bots on some of the other things where they're not going to be as efficient. Those more centralized things like OCR, machine learning, that sort of thing. So from an RPA perspective, you also have a unique capability. We're able to kind of dynamically allocate and spin up bots, but you're also able to share those bots across processes. So this allows you to also minimize your need to come up with the math equations of how to optimize your bots. You can basically spin them up with Control Tower when you need them and spin them down for that process to share with other processes. So some of our customers are using 60 bots, where other vendors, they might be using a few hundred bots, and in doing so, they have higher bot costs and they have a lot more infrastructure to be able to do the same type of work. Now, if you still want to do that structured approach, if you still want to only use one bot per process or a handful of bots allocated to specific processes, you can do that. You can do it kind of the old way, the structured way, but typically you'd want to do it where you're sharing those bots across processes to be as efficient as you can with the bots and the underlying infrastructure. So I came back to that at the end because it's easy to get deep into the really new stuff, which is the machine learning, but I also wanted to make sure that we are still an RPA offering, and we still do have a lot of customers that are only using us for RPA. Actually, more and more customers using us only for RPA because they want to get started with some of the ones where they can define some of that up front. But then they have they have access to machine learning when they need it, and they can either do it right away in process 1, or they have it for process 5 when they've done more RPA as well. So differentiation, because we have access to machine learning, but then also some differentiation in the RPA side just to kind of finish with that part there. So any questions about RPA, which I kind of snuck in here at the end, or final questions with machine learning before we take a quick break?
It's Nathan here again. So I guess if you could sum it up in just 2 sentences, right? What would the value add be for not for RPA obviously, but for going with WorkFusion? So you mentioned one, obviously the machine learning capability is a big piece, right? But in general, if someone was to ask me to give them like a one sentence overview, all right, of why they should consider WorkFusion over, say, Blue Prism or something like that, what would your answer be to that?
I would say more efficiency from an RPA perspective, because you have access to the dynamic bot allocation capability, and you can use fewer bots to automate the same thing. And you have AI today if you want AI today. You don't have a path to AI, you have AI, you have access to it, you can put it in your processes now on your premise with regular hardware out of the gate. So a couple of long sentences, but kind of a equation sentence from an RPA perspective, but trying to differentiate, saying we have a better way to do RPA. But then from a machine learning perspective, it's not just that we have machine learning, it's that it's integrated, it's available today, it's for their data, it's using existing hardware within that's ready to go right now.
Yep, perfect. Thanks, man.